York Dobbins, a theoretical physicist who joined the staff in 1987, has done much of the statistical analysis and has considerable interaction with the critics of P.E.A.R's work.
They pick out things like, do operators cheat? Do operators have a chance to meddle with the data? Do our statistics really mean what we think they mean? What are the possible physical confounds, such as ordinary electricity, magnetism, and what have you? Of course, we've had years to refine the experiments and think about possible loopholes that we can then plug. With the REGs, for example, they are shielded against most of the sorts of interference that you can think of.
The process of mechanical design at P.E.A.R involves extensive calibration and testing to search out and eliminate artifacts in the data that correlate with known physical processes. These designs were abandoned because they could not be sufficiently insulated to produce truly random data. Temperature and pressure created artifacts in this Crookes tube design, this dual thermistor design, and another using photoelastic stress. The first fountain design showed acoustic artifacts. Another machine responded too sensitively to vibrations in the building. The machines that do survive P.E.A.R's testing and go on to be used in experimental work are known to be free of interference from known physical processes and produce random data that fit chance expectations.
We calibrate our experiments extensively under actual working conditions and find that in the calibrations they produce data that are consistent with the null hypothesis. And finally, for most of our experiments, we use a tripolar protocol in which the only difference is some aspect of the human being's mental state. Basically, any physical confound that you can come up with has to be not only able to get through all of the shielding and equipment design and for some reason not be present while the machine is calibrating, but it needs to be smart enough to track what the operator is doing subjectively.
Through the years of refining experiments and statistical processes, this unexplained phenomenon remains. The resistance by mainstream science has also continued, and has created many difficulties, not the least of which is the dissemination of their work.
This has been unfortunate in the sense that it has restricted the flow of information from this field into other fields that would benefit from it and who could benefit the field.
We even had an encounter with the editor of a prominent scientific journal who, when asked if he would consider publishing this paper, he said, when Professor John and his colleagues can transmit their manuscript to my editors telepathically, we might consider it. Well, how do you go through the scientific process of peer review and et cetera, if you can't have peers, if you're not allowed to present the data and you're not allowed to deal with it critically on a rational scientific level? So you end up getting irresponsible criticism. You end up getting unreasonable rejection, not on the basis of the quality of the work, but on the topical matter. In my view, that's not science. That's not what science is about. Science is about opening your mind to learn something new. It's not saying, this is something I don't want to hear about. This is the sort of thing, as one critic said, I wouldn't believe in even if it was true.
And one of the things that has become fairly evident in the history of the field is that the definition of what constitutes an overwhelming weight of evidence and what constitutes impeccable documentation tends to get more and more stringent as the evidence and the documentation accumulates.
Even if mainstream scientific journals have not considered their work, the popular media has not been shy. The P.E.A.R Lab has received much press coverage over the years, and the popular response to the work is generally positive.
Mind over matter. It used to be just a figure of speech, right?
If I flip this coin, I'm supposed to have a 50-50 chance.
So can people affect objects and machines with their minds?
It would appear they can.
As the P.E.A.R lab prepares to close its doors in the coming year, they leave us with a compelling and perplexing set of indications.
The phenomena are real. They aren't just due to chance effects. They're small, but those small effects compound over many, many occurrences. They don't seem to be associated with processes that we think of as cognitive. We don't see things like learning curves. We don't see any of the usual things associated with cognitive, perceptual psychology. We know that they tend to appear more a beginner's luck effect or series position effect, where people tend to do better the first time. We notice that they seem to be distributed across the entire distributions of the outputs. It's as if the probabilities are being changed rather than the physical activity. We've seen these cooperator effects where people of opposite sex, and especially people of opposite sex who are bonded couples, are resonant with each other, tend to get stronger effects than individuals. The field reg data have shown us that we get effects when we're in groups of people in environments where there are a lot of people who are on the same wavelength. We have seen gender differences. Males and females, on average, produce different characteristics in their data. They are independent of distance and time. All of these things, of course, are challenging any attempts to model them, because these things just don't fit with our prevailing understanding of the way the world works.
Compounding the results across all of our experiments, all of the time we've been operating, you then come out saying that the results you find in this composite database are unlikely by chance to better than 1 part in 10 to the 12th. That's 1 part in a trillion. This is far more stringent than any science experiment I'm aware of requires for its validation. The physical theories need to be expanded for their purposes. For the purposes they have been applied in other sectors, they are remarkably effective and accurate. But in situations such as we're dealing with here, where we are exploring interactions between the human mind and random physical processes, they lack several important ingredients. Whether or not the ultimate theories of these phenomena will follow in a strictly Bayesian format, I honestly don't know. But I do know that we cannot expect the sort of rigid causal determinism replication that has ennobled much of our science in other areas.
To find out how this phenomenon works is a puzzle that will remain long after the P.E.A.R lab is gone. P.E.A.R's theoretical models are only the beginning of the search.
So much of P.E.A.R's effort has been toward trying to demonstrate, trying to convince, trying to make the case that the phenomena are real. The next level of inquiry is, okay, they're real. What are they? How do they work? Where do they apply?
Yeah, the search is indeed for the mechanism by which such information is acquired, or indeed possibly even created.
I think P.E.A.R has done what P.E.A.R had to do. There's just so many random binary events that you can generate. If we haven't made our point with the databases we've accumulated over the last quarter century, we're not going to make it. But to take it further, to talk about the implications and how that may affect other fields, that's for the next generation to do.
These experiments, technically speaking, are not difficult. The phenomena, conceptually speaking, are extraordinarily difficult If indeed, as we contend, these events are intrinsically, subjectively driven, then it follows clearly that the researcher must be experiencing them himself. So don't take our word for it, don't take others' words for it, go off and try it yourself and come to your own conclusions based on your own experience.